Thank you, Professor Gay. Good morning, ladies and gentlemen. John Robling was one of the most visionary bridge engineers of the 19th century. He pioneered the design of suspension bridges, for which he initiated the use of stay cables to stiffen them. Man Chung Tang already yesterday mentioned that briefly in his talk on bridge development. After World War II, the use of stay cables was rediscovered, and the new type of cable-stayed bridges became very successful. The development Robling started 150 years ago are still in progress today. Johann August Robling was born in 1806 in Mühlhausen, Thuringia, only about 80 kilometers away from here. He attended the Academy of Civil Engineering in Berlin, and after initial work for the state on various civil projects in Germany, he emigrated in 1831 to the US. After receiving US citizenship in 1837, he changed his name to John A. Robling and started again to work as a bridge engineer. His breakthrough came with the Niagara Falls Bridge, with a record span of 251 meters in 1851. The main problem for this long-span railway, I underline railway bridge, was the required stiffness of the girder for the high railway loads. Robling achieved the required stiffness in two ways. On one hand, he used a stiff 6-meter high timber truss for the beam, and in addition, he used stay cables. The Allegheny River Bridge in Pittsburgh was completed in 1860, for which Robling again used the principle of combining suspension cables with stay cables. One idea was, of course, to stiffen the suspension bridges against wind oscillations. Most of the early cable-stayed suspension bridges failed due to wind oscillations, and he, more intuitively than calculation-wise, introduced the stay cables to stiffen suspension bridges against wind oscillation. We come to that later. The progress of Robling's design for the Cincinnati Bridge, with a record span at that time of 322 meters, was interrupted by the American Civil War. The crowning achievement of John Robling's work as bridge designer was the Brooklyn Bridge in New York, with a new record span of 486 meters, which he started to design in 1865, right after the American Civil War. This, what we see here, is one of his preliminary drawings for stay cables. He couldn't really calculate with the tools of that time statically indeterminate systems, but he tried to balance the dead weight, one half for the stay cables and one half for the suspension cables. Robling had completed the design for this bridge, and the work for the foundations had started when he died from an accident on site. The construction of the bridge was completed by his son Washington Robling, and finally by Washington's remarkable wife Emily Warren Robling. There's a biography out called Silent Builder on Emily Robling, and shows what an outstanding, amazing woman she was to take over the job and finish it successfully. Stay cables are still used today to strengthen suspension bridges. The Tamar Bridge was widened by 2 outer lanes. For supporting the additional loads, stay cables were installed. That was quite recently. Why are suspension cable-stayed bridges so much stiffer against